All right, here goes. Section 7.7. This is the second to last section for us this semester. So we're closing in on the end of things here. So this is one of my favorite sections in the whole class because it begins to expand our knowledge a little bit. So I don't know if you've seen this before or not. Again, my presentation doesn't require that you have. So what we're going to talk about today is something called complex numbers. And complex makes it sound like they're difficult to work with. They are not. Everything that is required to work with complex numbers are skills that you already have. Okay, so there's going to be one bit of new information. I'm going to give you a definition, and then we are going to practice it with things that we already know how to do. So where do complex numbers originate? Well, if we consider the following equation, x squared plus 1 equals 0. Now, if you remember when we were in chapter 5 and we talked about solving equations that have a squared on them, right now, up till this point, you only know how to solve one of these by factoring. And unfortunately, this won't factor. It's not a difference of squares. It's a sum. Okay, and I told you back in the day that those do not factor. So what we're going to do is approach this a little different. And so what we're going to do is we're going to subtract 1 from both sides of this equation. And we're going to end up now with the equation x squared, because the 1's on the left cancel. We're going to have x squared equals -1. And then since we have the x squared, we encountered this situation with the Pythagorean theorem. What we're going to do is we're going to take the square root of both sides. And so we end up with this answer to the problem, that x, the solution to that original equation, is the square root of -1. Now, up till this point, if you remember when we began chapter 7, and we talked about square roots of negatives, I said that's not defined. Okay, we don't have a value for that. We can't take the square root of a negative number. There is no whole number times itself that's going to give you a negative, and that is still true. And so what some crazy math person did at some point in the past is they made the following definition. They invented a solution to this equation. And so that's where we get the next thing, which is the definition of the imaginary unit. This is the new material for the day. Okay, this little blurb right here. The imaginary unit is I. Okay, I for imaginary unit. The imaginary unit is defined as follows, that I is equal to the square root of -1. Basically, what we're saying is that I is the solution to that original equation. Where did this come from? Some mathematician invented it. By the way, it says imaginary unit. This is actually one of the, if any of you go forward and you become any sort of engineer, you're going to see I a lot. It's actually quite applicable and useful in things like talking about waves. My daughter's an electrical engineer. She uses the complex unit all the time. So for something defined as imaginary, it's actually a very useful thing. So the imaginary unit I is defined to be the square root of -1. And that means if I square that, I squared is -1. So this is what you need to remember for this section. Okay, this is the new information that we encounter, is this definition of the imaginary unit. And now we're going to go through and we're going to work with this. And all we're going to do from here on out with our imaginary unit is we are going to use it in ways that we already know how to use things. So here's an example. It's not on your page. I'm going to start with a little bit of an easier example than my first example. What we're going to do first is we're going to write, I'm going to use these instructions right here. Write each expression in terms of the imaginary unit, but I'm going to start with this example right here, the square root of -25. Now that we've defined it, we're going to talk about simplifying it. Okay, remember back in section 1, we wrote down the answer to this as it's not defined because it's the square root of a negative. But now we've defined it. Okay, so here we go. I'm going to use the product rule of radicals. And after we've done a couple of these, you probably won't need to write this step down, but I'm going to here. So -25 is -1 times 25. Product rule of radicals says that when you have a multiplication under there, you can give them each their own radical. So I have the square root of -1 times the square root of 25. And so here's what I've got, the square root of -1. You tell me, what is the square root of -1? It's I. It's defined to be I. Okay, that's the thing you've got to get used to today. The square root of negative 1, whenever you see this right here, we look over to the definition. Oh, that's I. And then the square root of 25 is 5. So what I've got is 5I. And what this is called right here, this is called an imaginary number. An imaginary number because it's in terms of the imaginary unit, 5I. Here's my example. I've got another one, and then you've got several that you're going to do. So the square root of negative 75. So again, I'm going to do the same thing. I'm gonna prepare to use the product rule of radicals. So square root of negative 75. Well, first I've got that negative, so that's negative 1. And 75 is a number that we've worked with before. What's the perfect square factor of 75? Yep, 25 times 3. Perfect. Now, again, you don't have to write this every time. On these first couple product rule of radicals says that's the square root of negative 1 times the square root of 25 times the square root of 3. I'm just giving each of those their own radical. And now we're going to take the root of what we can. So firstly, the square root of negative 1. What's the square root of negative 1? It's I, yes. Square root of 25 is 5. We just saw that, so I'm going to put that. Now, normally what we do, the convention is when you have a whole number, you write it in front of the I like it's coefficient. And then this square root of 3, I'm going to write it after the I just because it's square root, and I don't want to accidentally write the I under the radical. So that tends to be how you'll see these things written. 5I square root of 3. All right, so you go ahead now. Exercise 1, right next door, is the square root of negative 49. I'm going to give you half a minute to go ahead and write that in terms of the imaginary unit. All right, so I'm going to write this out. If you wrote less, that's fine. I understand that the product rule of radicals is not something we have to write out every time. So here we go, negative 1 times 49. And now here we go. What's the square root of negative 1? That is I. Okay, that's the thing I'm trying to get you used to here. And then the square root of 49 is 7. So we have 7I. Okay. We doing all right with that? Question, comment, concern for me? All right, exercise 2. Go ahead and write that in terms of the imaginary unit, please. All right, so this one, there's a little less work to do, okay, because 7 is a number that doesn't have a perfect square root. So what I'm just going to do is I've got one thing. I'm going to take the square root of negative 7 is negative 1 times 7. And so then again, here we go. This is the part I'm getting you used to. What's the square root of negative 1? It's I. Thank you. Appreciate that. And then the other part is the square root of 7. 7 does not have a perfect square factor, so it's just I times the square root of 7. That is it. Exercise 3, right next door. Simplify and write in terms of the imaginary unit the square root of negative 54. So the square root of negative 54, again, that negative sticks out like a sore thumb. So we've got the negative 1 and then 54. What is the perfect square factor of 54? It's 9 times 6. Wonderful work. I appreciate all of you. And so then the square root of negative 1, this is the new bit of information. The square root of negative 1 is I. The square root of 9 is 3. I'm going to put the 3 in front of that. And then the square root of 6, there's no other perfect square factors, so I just have the square root of 6. That is now written as an imaginary number. Excellent. Okay, so first skill for you today to remember, this will be on the test, is writing radicals in terms of the imaginary unit. Okay, we just did those 3 or 4 examples of that. Here is skill number 2. What if I have two negative numbers under the radical that I'm multiplying together? So for instance, example 2 says I have the square root of negative 5 times the square root of negative 6. Now, I know what you want to do. I want to do it. We all want to do it. We just want to say, oh, okay, this is easy. Negative 5 times negative 6 is 30. So this is the square root of 30. Not quite, okay? Because we're dealing with imaginary numbers here, here is what you have to do. Okay, first thing you have to do on this problem is you have to write them in terms of the imaginary unit. That's the first thing you have to do, is write these in terms of the imaginary unit. Okay, this is just what we've been doing. This is not new. So I'm going to go ahead through this. So we've got the square root of negative 5 is negative 1 times 5. The square root of negative 6 is negative 1 times 6. Okay, we just did that with the problem right above that you can still see on the screen. Square root of negative 1 is I. And then I have the square root of 5. Square root of negative 1 is I. And then I have the square root of 6. Now, here's where you got to start paying attention again. Okay, because now we're going to have another part to the definition that you've got to remember. So keep your eyes on that definition of the imaginary unit a little bit up your page. So when I multiply these together now, the square root of 5 times the square root of 6, that indeed is now the square root of 30. What do you think I times I is? How do you write that? Perfect. If it was x times x, it would be x squared. I times I is I squared. Now here's my question. According to the definition that you see a little bit up the page, what is I squared equal to? It's equal to negative 1. So this is negative 1 times the square root of 30, or just negative square root of 30. And I got that again. I squared, this is part, the definition of the imaginary unit is I equals the square root of negative 1. And then the related bit of information is that I squared equals negative 1. These are the 2 bits of information that you have to commit to memory. Okay, these are super important. Okay, especially when you get to college algebra. If you go beyond college algebra into trigonometry or pre-calculus algebra, you're going to deal with imaginary numbers all the time. Okay, exercise 4, it's very similar to what I just did. So go ahead and give that a try. Write both of those numbers as imaginary units and then multiply them together. All right, so first thing I'm going to do is write both of these numbers in terms of the imaginary unit. This problem is just like what you were doing in the previous problems. So the square root of negative 4 is negative 1 times 4. The square root of 16 is negative 1 times 16. The square root of negative 1, that's our definition. That's our new piece of information today. That is I. The square root of 4 is 2. So that first thing simplifies to 2i, 2 times the imaginary unit. And then the second one, again, the square root of negative 1, the square root of negative 1 is I. And then the square root of 16 is 4, 4i. So far, are we so good? You doing all right with this? I know sometimes it's only the one definition, but it is a little bit of a goofy thing, you know, talking about the imaginary unit. So if you got any questions, let me know. And now when I multiply, what's 2i times 4i? What do we write down? Yep, 2 times 4 is 8, and then I times I is I squared. So we have 8i squared. And then the last thing to do is now we refer to that definition up above, and 8i squared is going to be equal to what? Perfect, perfect. I squared is negative 1. So this is 8 times negative 1. If you want to write that down, 8 times negative 1, and that becomes negative 8. Perfect. One more like this, exercise 5. Same thing. It's just like the problem I did that's right above it. Okay, so just like the previous problem, the square root of negative 7 is negative 1 times 7. The square root of negative 11 is negative 1 times 11. Now I'm going to first write these in terms of the imaginary unit. Everywhere you see the square root of negative 1, that becomes I. So that's I times the square root of 7. And then this one is I times the square root of 11. I times I is I squared. That's going to come up a lot on at the very end of our page. So when we go to page 2 down at the bottom, just keep in mind I squared is equal to what that's equal to. So square root of 7, square root of 11 is square root of 77. And then I squared is negative 1, so negative square root of 77. Okay. We're still doing okay. All right, so then what happens with our imaginary units, our imaginary numbers, is we create a whole new number system from them called the complex numbers. And so if A and B are real numbers, now real numbers, remember, are just any number you're used to working with, any decimal, any fraction, any square root, pi, any whole number, negative number, they're all real numbers. So if A and B are any real numbers, then any number in the form a plus bi is called a complex number. It's called complex because it has 2 dimensions. It has a real part and an imaginary part. The number a is the real part. The bi is the imaginary part. And so then here comes our number classifications. A is a real number. A is just numbers we're used to working with. B times I, as I mentioned up above with my very first example, this is an imaginary number. Anytime you have an I associated with something, it's an imaginary number. And then when I link them together, A plus BI, this is called a complex number. And in fact, in our new number system that gets created, all of these, I could call any of those a complex number. Just each of them are specific. This is a complex number that is strictly a real number. This is a complex number that is an imaginary number. And this is a complex number that has both parts. And that becomes our new number system. We're going to only, in this class, we're only going to touch on this briefly, use a little bit on the second page of this sheet. And then when we come back in our last section, we're going to solve quadratic equations again. And then when we solve them, we're going to see that we can get complex answers to quadratic equations. And we're going to see how we do that. Let's flip the page 2. And all we're going to do for the rest of our time together, however long that is we are going to perform operations with complex numbers. Okay, I don't think it's going to be anything that traumatizes you. It's just like stuff you've already done. So for instance, before we do example 3, this is my example. We're going to add the complex number 8 plus 3i. And we're going to add it to the complex number -2 plus 14i. I just want to remember a skill you already have. Let's say that we had this problem right here. Let's say that we had 2x plus 5, and we were adding it to 5x plus 9. What do you do in that situation when you go to add those together? What parts go together? Like terms, right? So that means I would add the 2x with the what? The 5x, and I'd add the 5 with the 9. So the 2x and the 5x, that gives me 7x. And then the 5 plus the 9, that's the 14. Okay, that's great. And so I just mentioned that because adding and subtracting complex numbers is just like terms. So what we're going to do is we're going to add the real parts together, and we're going to add the imaginary parts together, and we get a new complex number. So here goes. 8 plus -2, that turns out to be 6. And then 3i plus 14i, what do you think 3i plus 14i is? That's exactly right. It is going to be 17i. Great job. Adding like terms. We're just adding the real parts, adding the imaginary parts. So your example of this right next door, example 6. Add those two complex numbers together, please. All right, when I add these two numbers together, what is going to be the real part of the result? The -11 plus the 14 gives me 3. That's the real part. And then the imaginary part is going to be 17i plus -12i. That is positive 5i. Anybody get anything different that we need to talk about? All right, then one more addition problem, exercise 7. That this time there are 3 complex numbers to add together. It's the same process. Again, we're just going to add those real parts together. We're going to add the imaginary parts together. So the real parts, -6 and -5. -6 plus -5 is -11. Plus 7 is -4. 2i plus -14i, that is -12i. And then plus 6, that is -6i. Okay, -4 minus 6i. Okay, again, don't be afraid to use your calculators on that, as we've said before. Example 4 is the same thing. It's just subtraction this time. I'm just going to remind you what I've told you to do in previous situations when we've talked about this. Whenever I have a subtraction, I always distribute. That way I remember to subtract all of my terms. I mentioned this when we were talking about subtracting rational expressions, when the numerators had multiple terms, things like that. So the 8 plus 3i, the first complex number, nothing changes there, 8 plus 3i. Okay, I've not changed that complex number at all. But what I am going to do now, since I'm subtracting, is I'm going to distribute this minus sign to both parts of the complex number. So I've got a negative times 2, that's negative 2. Then a negative times a negative 6i, a negative times a negative is plus 6i. That way I avoid any sign errors. It's a super common mistake to make. It's real easy to slip up and forget to subtract that second term. So when I distribute, I don't do that. So then 8 plus negative 2 is 6, and 3i plus 6i is 9i. So there's a subtraction term right next door for you. Go ahead and give that one a try. I'm going to subtract. I'm going to distribute that negative. So I've got negative 12 plus 3i. Notice that first complex number does not change at all. And now I'm going to distribute. So a negative times 8 is negative 8. A negative times a negative 5 is plus 5i. And when I now go combine my like terms, negative 12 and negative 8 is negative 20. 3i and 5i is 8i. And there we go. There is my answer. We doing all right still? Anybody got any questions at all for me? We got plenty of time today. Okay. You're not going to miss any of your Thanksgiving, I promise. All right, well then exercise 9 combines both adding and subtracting for you. So go ahead and give that one a shot, please. I know that in this case, there's multiple ways you could approach this problem. What I'm just going to do is I'm first going to distribute that negative, and then I'm just going to go ahead and add all of my real parts and imaginary parts. Other ways you could do this is you could go ahead and add these two together and then distribute and then go about finishing the problem. Just as long as you get to the same finish line that I get, it's all good. Okay, so the first number is not going to change, 13 plus 7i. Since this is a plus, the next one is not going to change, 2 minus 9i. Now I've got the minus, so I've got minus 3 and then minus 7i. There we go. And now I'm going to add my reals, add my imaginaries. So my real parts, 13 and 2 is 15, and 15 minus 3 is 12. That's the real part of my answer. And then my imaginary parts, 7i plus negative 9i, 7i and negative 9i, that's negative 2. And then negative 7i, that is going to be negative 9i as my result. So that's adding and subtracting complex numbers. It's just a matter of combining like terms, nothing different. So we're going to talk about one more operation. We're not going to go into division or anything. If you take college algebra, you'll learn how to divide complex numbers. You'll learn how to do powers on complex numbers. We're going to finish our discussion in this class on multiplying complex numbers. Okay, again, it's something that already uses all the skills that you have up to this point. You just got to remember a little of the definition. So for example, this one right here, example 5. I'm going to take 5i, that imaginary number, and I'm going to multiply it times 6 minus 4i. Okay, just a problem distributing. So here we go. 5i times 6. When I multiply 5i times 6, what do you think I'm going to get there? 30i? Great. And then when I multiply 5i times negative 4i, what do you think I'm going to get there? Negative 20i. It's I times I, so it's going to be I squared. Yes, great. Now we're going to do one more thing because we got that I squared, and we dealt with that a little bit already. What is I squared equal to? Negative 1. Okay, so also the traditional way to write a complex number is you write the real part first, the imaginary part second. I won't mark it wrong on the test if you don't. I think my math lab will be a little fussy on that. But you write the real part. So here's what I want to do. Negative 20i squared. That's negative 20 times negative 1. What is this term going to be? What does that become? Positive 20. Okay. Everybody with me on that? Okay, that's big. That's going to, every one of these last problems that you're going to do, that is going to be a little bit of trivia. So negative 20 times negative 1, that is 20, and then plus 30i. That is my complex number answer. All right, well, go ahead and try exercise 10. It's the same thing. You're going to distribute right there. All right, so here goes. Let's see how you did. Interact with me. Give me some feedback if there's some stuff here you're struggling with. So the negative 3i times the negative 6, negative 3 times negative 6 is 18i. That's my first term. And then the negative 3i times 12i. Negative 3 times 12 is negative 36. I times I is I squared. And then since this is I squared, what does that second term become? Becomes a negative 1, so negative 36 times negative 1 is 36. Wonderful. Beautiful job. 36 plus 18i. Yes, great. Here's my last example. We already did this when we were talking about multiplying roots before. So again, there's nothing new or mysterious here. Example 6, I'm going to multiply both of these complex numbers together. And since they both have 2 terms, we're just going to implement once again our ability to FOIL. First, outers, inners, lasts. Okay, so I'm going to do this one. Then you've got 3 that we're going to do one at a time. First, outers, inners, lasts. So on example 6, my firsts are going to be 2 times 4. That's going to give me 8. My outers are going to be 2 times 7i. That is 14i. My inners are 3i times 4. That's negative 12i. And then finally, my lasts, negative 3i times 7i. Negative 3 times 7 is negative 21. I times I is I squared. Before I tally up what that's equal to, this last term, negative 21i squared, what is that going to become according to the definition? Yep, it's negative 21 times I squared, which is negative 1. So negative 21 times negative 1 is plus 21. And so let's add those like terms up now. So I've got 8 and 21, that's 29. And then 14i minus 2i, or excuse me, 14i minus 12i, that's plus 2i. All right, so like terms, exercise 11. Give it a try. Do your foiling. We'll compare notes in a minute. If you got any question, please let me know. All right, first outers, inners, last. Let me know if you're getting something different than I am. So my firsts, when I do this, negative 1 times 4 is negative 4. My outers, negative 1 times negative I, a negative times a negative is plus 1i, or just plus I. My inners, negative 6i times 4, negative 6 times a positive 4 is negative 24i. And then finally, negative 6i times negative I, a negative times a negative is positive 6, and then I times I is I squared. That last term, what does that last term become when I take into account the definition? Negative 6, indeed. All right, we're about ready to finish. I've got my real parts are negative 4 and negative 6, that's negative 10. And then my imaginary parts are plus 1i and minus 24i, that's minus 23i. Good? All right, we only got 2 more, so if you got anything at all, let me know, okay? So exercise 12, boil those 2 together for me, please. All right, first outers, inners, last. Here we go. My firsts on this one, 7 times 3, that's 21. My outers, 7 times negative 2i, a positive 7 times a negative 2 is negative 14i. My inners, 2i times 3, 2 times 3 is 6i. And then finally, my last 2i times negative 2i, a positive times a negative is negative 4i squared. This last term, negative 4i squared, what does that become? Positive 4. Anyone not see how we're getting that? That's really the key thing. Okay, if you're doing good, you're going to do amazing on this next test we have when we come back from break. Okay, so this is exactly what it's going to look like. So I've got 21 plus 4, that's 25. And then negative 14i plus 6i is negative 8i. All right, last problem for the day. One more foiling. Multiply those last two complex numbers in exercise 13. All right, here we go. First outers, inners last. So my firsts on this problem, 5 times 6 are 30. Outers, 5 times 3i. 5 times 3 is 15i. My inners, 2i times 6. 2 times 6 is 12i. And then finally, my last, 2i times 3i. 2 times 3 is 6i squared. One more time. This is the last time I'll ask it. 6i squared becomes what? Negative 6. Indeed, that's true. And so here we go. 30 and negative 6 is 24. 15i and 12i is 27i. All right, that's our overview of complex numbers.